Okay, so this example is actually to show you a common pitfall that a lot of students make when they're rounding. It's when not to round. So the problem is this: a cart begins its rest and accelerates down a ramp with acceleration 0.518. So that's got three significant figures, and you're asked after 3.2 seconds how far has it traveled. Well, you use d equals 1/2 at squared, so you can start by figuring out what t squared is. So if t is equal to 3.2 seconds, you could say that t squared is, plug that into your calculator, 10.24 seconds squared. So d is 1/2 at squared is equal to 0.5. That's it's assumed that this half, by the way, has an infinite number of significant digits, times the 0.518 is the acceleration, meters per second squared, and then 10.24. And you get d is equal, plugging into my calculator, 2.65216 meters. And then we round that to two significant figures. So d is equal to, this is a 5, so it goes up, 2.7 meters. Okay, so that's correct. So let's do that again, but let's round early. So we say that t is equal to 3.2, t squared is equal to 10.24 seconds squared. So if we round to two sig figs, then what we get is t squared is equal to 10 seconds squared. So now we can plug that into d equals 1/2 a times t squared, and we get 0.5, we get the 0.518 and the 10, and when you work that out you get 2.59 meters, and round that if you want the two significant figures, and you get 2.6 meters. Okay, this is wrong. What you've done here is you committed rounding error. You've rounded too early. You've rounded an intermediate calculation to two significant figures and then plugged it in, and you've ended up with the wrong answer. So that's just a little caveat about what not to do. Don't round until you do the final answer. And the only reason you round at all is because you don't want to mislead the reader that your final answer has more precision than it does. So when you have intermediate calculations like the t squared here, just leave lots of decimal places.